Now in these questions, as long as you know what you need to do, they're fairly simple and easy to complete. So here's the idea for this. When we use the left Riemann sum, that's what we want to find. So two n's at the end of Riemann. It's a German mathematician, very famous for his work with integrals. The idea is to estimate the area underneath this graph, between the graph, right, and the x-axis. So we want to estimate this area, but because this is difficult, the idea that Riemann had was to actually use these rectangles that are drawn on this page. So we're taking the base, the x-axis that goes from 1 to 5, so 5 minus 1, that's length 4 in the base, and we're going to divide that in 4 subintervals. So 4 divided by 4, that's 1. And each of those subintervals, each of those subrectangles will have base length 1, right, because of this math we just did. So we're going to find an approximation for the area that has 4 terms, each of which is the area of that rectangle, one of those rectangles. And so for the first rectangle, I'll have base, which is 1, times height. And since I'm doing left Riemann sum, the height will be f of the left side point. So f of 1 plus 1 times, so the second rectangle, this is base 1 again, but then height is f of 2 instead. I'm doing the left point. And then 1 times f of 3 plus 1 times f of 4. So that will be, so f is given to me, right? So that's pretty simple. 1 times 3 over 1 plus 3. And you now start to see why I have my calculator there on the left side. It's not that difficult to math, but I don't think it's a big deal to avoid it, to use a calculator with it. And I shouldn't have to repeat the ones that I have because I'm just multiplying them by 1 anyways. That's just 1 times anything is just 1. Let me correct that. 1 times anything is just that thing. So that's going to be the left Riemann sum for this. And I'll just do my math. 6. Wonder if I want to do this. I think I'll do this in decimals. So this is 1.5 plus 3 plus 1 plus 3. So that will be a 4. So 3/4 is 0.75. So 3.75. And I'll just add the whole thing. Getting lazy, so that's 10, 13, 14.5 plus 3.75. So what will that be? 17, 18.25. Check my math and let me know if I got this wrong. But you got the idea. Up to this point, I'm pretty sure I'm correct. Below this is just arithmetic. You just got to do the math and check to see if this is correct. And on the right Riemann sum, the idea is exactly the same, except that now we're using the right point to do the math and to determine the height of a rectangle. So that's the right Riemann sum. 2 n's at the end of Riemann. So then the sum of the 4 areas of 4 rectangles will be area 1 times f of 2 plus 1 times f of 3. So we're doing the right endpoints. 2, 3, 4, and 5. That's the right Riemann sum. So I'll do this normally, but then at the end I'll show you something. Which is 3 over 2 plus 3. 3 over 3 plus 3. And maybe you noticed that yourself. But if not, I'll show you. what's going on here is that these terms are the same as these terms. Just take a second to notice that. So if you're trying to be clever to check your math or do the math faster, you could subtract the 6, throw that away, get a 12.25, and then add this, which is a 3.6. That would work. But then I just do the math normally. So that's 1.5 plus 3, that's a 3.5, plus a 4, sorry, a 4.5 plus a 4, plus a 3.75, plus a 3.6. So I'll do the math here in my calculator. Like I said, I don't think it hurts to check it, especially if you were tired or if you're doing math after in a long exam. Then you get the 15.85. The idea then, this is all the problem asks, but just to show you, to explain the idea of this question, what we're interested in is to find out what the actual area was, remember? So the first left Riemann sum was an overestimate because you can see there's extra area here on the top. So this is too much. 18 is too much. And 15 is too little because there's area missing. Right? You want the whole area. You wanted all this. So what could you do, right? Maybe the average is a good estimate, right? Or you could increase the number of subdivisions. And that's the whole idea of integrals that you'll see in a later class.